Wow, it's nice to see full house. Good afternoon, everyone. Now after the intro, who's already excited? Raise your arm. That's great to see. So thank you all for being here today. It's amazing to see that actually so many of you signed up for today, considering that the whole event actually started with a simple LinkedIn message. Now, we are honored to have a distinguished guest with us, someone whose contributions to the field of aerospace engineering have been truly groundbreaking. We are delighted to have him here, Dr. Hans Königsmann. Now, he has been a pivotal figure in the world of space exploration, serving as the Vice President of Avionics and also flight reliability later at SpaceX, and being the company's 4th technical employee. His expertise and leadership have played a crucial role in numerous successful missions. And all of this somehow started here at TU Berlin. Here is where he did his diploma before pursuing a doctorate in Bremen and then making the decision to cross the pond and build rockets in America. Today, he will be sharing his insights and experiences from his remarkable career, offering us a glimpse into the future of space exploration. And last but not least, in the last third of today's session, he will also answer your questions. But for now, I would like to hand over to our Vice President at TU Berlin, Professor Fatma Dennis. Thank you very much.
Hello. Dear Dr. Königsmann, dear Mrs. Hachmann, dear esteemed guests. On behalf of the entire executive board of TU Berlin, I'm very delighted that you, Dr. Königsmann, have accepted the invitation of our dedicated students and that we are able to welcome you here in our beautiful Audimax today. Like our esteemed alumnus, Dr. Königsmann, many of you began your academic journey here at our university. An exciting journey, an intellectual adventure, with a clear mindset and goal. We want to develop science and technology together for the benefit of our society. TU Berlin is therefore a place of learning and research. It's also a place for dialogue, exchange, and coming together, where people from different backgrounds, disciplines, and perspectives learn with and from each other to create, share, and disseminate knowledge together. Dr. Königsmann, we are therefore really grateful and greatly indebted to you for your sharing your experiences and insights with us today, which you have gained during your remarkable career. I think it's no doubt that you are a role model for countless people in this room and also outside, and inspire many students through your work to pursue their dreams and push the boundaries of what is possible. As an aerospace engineering alumnus, you have laid the foundations at TU Berlin to solve complex problems and develop innovative solutions with your passion for aerospace. When I look at your career, it shows that with hard work, passion, and determination, even the boldest dreams can be achieved. And I think you embody, in fact, the values and set standards that we also are upholding at TU Berlin. Excellence, innovation, and the courage to rethink and to break new ground. Our university, as part of the Berlin University Alliance, we collaborate not only with outstanding international partner institutions, but also with other leading research institutions in Berlin and Brandenburg, always with the goal to jointly address the most pressing issues of our time. from climate change to new technologies, digitalization, and innovation in business models. And together we strive to help shape the world of tomorrow from our lecture halls and laboratories into the society. You, Dr. Königsmann, once said in an interview that we need tasks that challenge our curiosity and intelligence. It's therefore up to us, the members of TU Berlin, but also business and politics, to ensure that we use the latest technologies and expand our knowledge to create innovative and sustainable solutions. Digital transformation here is playing an increasingly important role. Digitalization is one of the most important factors in shaping our future. It's of social importance, of course, because it enables new forms of knowledge transfer, and it's also of economic importance because it has a massive impact on the competitiveness of our companies. But let's be honest, it's also progressing way too slow for us here. And we have to work on this, and we are working on this. The topic is not just a discipline of computer science, of course. In order to be successfully implemented, it requires the interaction of many disciplines in industry and academia. At TU Berlin, we conduct cutting-edge research in digitalization, from machine learning, the future of work, to digitalization of water system, to digital health and medicine. With the Einstein Center Digital Future, ECDF, and Bifold, our big data management and machine learning centers, TU Berlin created two interdisciplinary lighthouse projects that deal with these aspects of digital transformation and their applications. And we in the executive board made digital transformation and data-driven sustainability a top priority. Dr. Königsmann, as one of the first engineers at SpaceX and as vice president of build and flight reliability at SpaceX, you played a crucial role in the development and success of this company. Under your commitment and leadership, SpaceX achieved several historical successes that, I have to say, as a person who once wanted to become an astronaut, watched it with extreme excitement, including the Falcon 1, the first privately developed liquid propellant rocket to reach orbit, Falcon 9, known for its reusable rocket stages, revolutionizing the space industry and significantly lowering the cost of access to space. And in fact, the Nano-Satellite Information Flight, short for NANO-FF, project here at the TU Berlin used Falcon 9 to put two small satellites that are produced at the TU Berlin into the low Earth orbit in 2023. So your achievements are not only technological feats, recognized also by the award of NASA's Distinguished Public Service Medal, but also testament to your quest to harness knowledge from distant worlds for our planet by translating it into technologies that generate clean energy, produce better food, and generally create less waste. We at the TU Berlin, and I, as the Vice President for Digitalization and Sustainability, have also made it our mission to strengthen climate protection and sustainability, also a hard topic for you, as I know, by implementing concrete data-driven measures. We integrate the topic into teaching, offer special modules and degree programs, put the findings of our scientists into practice on the way to climate-neutral campus, and support our members in their personal commitment to climate protection. We do target this commitment to scientific research into climate change and sustainability as a high priority, emphasizing it in an interdisciplinary approach. We have the Clusters of Excellence Math Plus, UNISYSCAT, short for Unifying System Catalysis, as well as our involvement in the Climate Change Center, Berlin-Brandenburg. And through our collaborations with industry and business, we work closely with our partners to develop innovative technologies and solutions and promote their application in practice. We have a Center for Entrepreneurship that teaches researchers and enables entrepreneurship with a threefold sustainable impact: economic, social, and ecological. And we support startups during their founding phase. When you, Dr. Königsmann, developed the BremSat satellite at the Bremen Center of Applied Space Technology and Microgravity in close collaboration with OHB, the company was still small, developing quickly, and supported by an enormous spirit. Nevertheless, they have shown that it is possible to go out into the world from the lecture halls and the laboratories of our university and make a significant contribution. So TU Berlin is really proud to have such a remarkable alumnus. Your success is a reflection to the quality of the education and the potential of our students. You are a living example for us of how the foundations laid here can open doors to extraordinary careers and role-changing opportunities. Dear Dr. Hans Königsmann, on behalf of TU Berlin, I would like to express our appreciation and deepest gratitude to you for accepting the invitation of our students. You are an inspiration for our university, the aerospace and scientific community worldwide, and you continue, in fact, to encourage our generations of students to reach for the stars. A warm welcome, and thank you very much.
Now it's time. I don't think we need a countdown for this, so please join me in giving a warm welcome to Dr. Hans Königsmann.
Thank you. Does this go there? Okay.
Hans, we're delighted to have you here today. You prepared a presentation for us today, so I'm looking forward. Thanks a lot. The stage is yours.
All right, thank you. All right, thank you. Good evening. I'm really happy to be here. It's and especially this turnout is amazing. That's way more than what I've been used to from 40 years ago. So, anyways, I'm not going to go through this again. I just want to go through the last part. So I'm semi-retired since October 2021, but I am advising companies that I think that I feel like are special, and that is in particular Stoke Space, which is in Seattle. They're building a reusable small launcher. Vast Space builds a space station. And Mandela Ventures and Alpine Space Ventures are funds, basically. But I'm also working in Germany on the OHB board of supervisory board. And then I'm also volunteering on the, at the National Academy of Science, Medicine, and Engineering in Washington. The whole thing started here, indeed. I did study at the Technical University of Berlin here, Luft- und Raumfahrt, and I started with airplanes. There's a reason for that. We might talk about that later. And then after doing half airplanes, I switched over to the satellites. In particular, I ran into a friend who worked for Professor Renner at the time. Professor Renner had the idea of launching or building a satellite called a TubeSat. The very first one actually did not fly. The very first one was more like a model, but that's the one that I worked on. It was called TubeSat 1. I think the first one that flew was called TubeSat A. But they're all related, and they're all basically getting more and more improved as time goes on. I also did some internships, and I wrote this down particularly because I wanted to point out things that are important. I did an internship at a pipe builder in my hometown. There was nothing special in that sense, but I learned how to work on a shop, basically. And then I did another one, and these are the original names, at Dornier in Friedrichshafen, now Airbus, and at Erno in Bremen, obviously now Airbus too. I thought those internships, in addition to university, were really important. In particular because you can't figure out whether you want to work there or not. But then one really weird thing for me was that I actually had more hands-on work at the TU than at those companies. And that surprised me a little bit. I thought at the time this might not be the average case, but I think what I saw today in the laboratory, I think they still have more hands-on work than what you will see in the industry. So that part, I think, has not changed. And then in hindsight, basically, I think TubeCert had a really huge impact on my career. And we basically tried things out. Professor Renner was just very curious, and we would do things that basically weren't quite, let's just try if this works. And then if it works, it's great. If it doesn't work, then, well, maybe we do the other approach. And today, this is called accepting failure or iterative design, but I believe this hasn't really changed. I did then, from here, I basically jumped over to the University of Bremen for a PhD. There was a project called BrainSat, which was very similar to TubeCert at the time. It had the same number of corners and used the same launch principle. That is what's called a getaway special container. And the satellite is inside. It's basically like a trash can that opens the door, and then the satellite gets kicked out. This was a cooperation between SARM, which is called the Center of Applied Space Technology and Microgravity, University of Bremen, OHB, TU Munich was there, and Uni Braunschweig at the same time. It flew, actually. It flew successfully in '93, worked for 1 year, and it actually did work properly. Well, it didn't really work 100%, but it worked enough so that we could make it work in a science sense. And I thought that was pretty amazing. And then by the end of 1995, I got an offer from a small company in Los Angeles. And the offer was to go there for a 2-year work visa, and we decided to do this. Anyways, that's 28 years ago, by the way. So I learned a couple lessons between TubeCert and BrainSat. One of them was about functional redundancy and stuff like that. One of them was test as you fly. Basically, that's something what we sometimes didn't do, so I learned that later. And then also we had like what's called a hardware in the loop simulator, which I think was a great way to test the satellite, because there's many things in space that you can't test on the ground, and that was part of it. Part of what was interesting to me, because I envisioned that you have to basically engineer it, and then you have to test it in ways that make sure that you actually test in space, that you work in space. And that was one of the challenges that I thought was really intriguing. And then the last not least, on the BrainSat side, as well as on the TubeCert side, it was amazing to see that it actually worked, and it worked with a team that had relatively little experience in the beginning. So switching over then to LA, I stayed, well, like I said, I stayed 28 years so far, but I stayed 6 years, I think, at this company called Microcosm. I worked mostly on projects for other companies, and then one day I ran into this guy, Elon Musk, and I think it was in February 2002, and he called me a couple of weeks later, and he asked if I would be interested in joining the team. At the time, there were 3 people at SpaceX, and I basically said right away, yes. And then we started in 2002. We didn't even have a building or an office or anything. We basically met at hotel meeting rooms for a couple of months, and then we finally found an office and moved in. But we started with a relatively small launch vehicle, called Falcon 1, and it was well, you could get your arms around it. It had 1.7 meters diameter. I guess that is pretty much that. 21 meters height, and it used the propellants liquid oxygen, and RP1 is rocket propellant or kerosene. We built an engine that was called Merlin, and that engine is the same, in principle, still the same engine that runs today on Falcon 9. We ended up launching from a small island in the middle of the Pacific, and that's a story in itself, how we got there. We launched 5 Falcon 1s basically from this particular island. It was called Omelek, and the first 3 failed. That was not easy. The first one actually had a fire on the wrong place. If you look at that picture over there on the right, you see a flame over the engine. That's not supposed to be there. And that basically burned through cables and through pipes and brought the vehicle down after just 28 seconds, came down, exploded on the reef, and then we collected it the next day, or we picked it up rather in pieces. The second flight got much further, but it had a control problem, and it spun out basically, and the propellant, when you spin the rocket, basically the propellant goes on the side, and at one point the engine did not get propellant anymore and just went out, and then the rest is basically just ballistic trajectory with a, landing in the ocean. Number 3 was tragic. Number 3 was, had a new engine, and that engine had a different way of turning off. The other engines turned off really hard, and this particular engine turned off a little bit softer. And so when we separated the stages, the first stage came back at the second stage, and then the second stage ignited inside the first stage, and that was not good. And so we made a little change for the fourth flight. We changed the time between engine shutdown and then stage separation. We made that, I don't know, a couple of seconds longer. So engine shutdown, wait, separate. And in that case, the thrust went all down, it separated, and the second stage fired. I should have probably mentioned it's 2 stages. and then everything was fine. And that flight actually reached orbit. There's a lot of history about that too, partly because Elon said he has enough money for 3 flights, and that was the 4th. So I guess we found some more. And it was actually an exciting year, so to speak, because we also launched flight number 3 or flight number 4 a month or 6 weeks after flight number 3. So we had 2 rockets actually that we could test. And then we flew 1 more vehicle from this island, and that was for a commercial payload called Malaysiasat, I believe, and that actually went to orbit, and that's kind of what we try to do. But in the meantime, we started building another rocket, and that's called Falcon 9. I have this is the place, the island is called Omelek. It's part of an atoll that's called Kwajalein. And it's that red thing there is where it is. It's actually really there. When you go from Los Angeles to Hawaii and then fly the same distance, the same direction, then you end up there, basically. And it's part of the Marshall Islands. It's an area that I didn't know at all. I didn't even know existed. And you may have heard about it from the Bikini Atoll and some of the hydrogen bomb or atomic bomb tests. It's a really amazing place. And so that's where we built the rocket. And this is how the island looked. This is probably half the island. So the other half is about the same size. You can walk around in 45 minutes. And it's about as warm as in Berlin. The vehicle that brought us to our job is on the upper right. Every morning I was riding this boat for 45 minutes and then going back 45 minutes, which happened to be, ironically, the same time my commute was in LA. And then down there in the lower right, this was the first flight. What happened is, the next time we basically went to the island, we picked up the pieces and then we brought them back to the hangar, and we just, this was not coordinated at all. We just put them on the ground where it came from, basically. And so I can't tell. I think this is the tip of the vehicle, probably. The engine is the other side. And so we just basically built these piles where they came from, and we were looking for certain parts, and took us actually years to find all of it at the end of the day. Picking up a vehicle is not a good day. Anyways, but after Falcon 1 flew, SpaceX developed Falcon 9, and that was a legitimate rocket. It was 70 meters tall. It had 3.6 meters diameter. That's 12 feet. It was 550 tons loaded, and it had a maximum payload of 23 tons depending on the orbit, of course. And it started in 2010. So just a couple years later. And as of today, as of yesterday at least, it had 360 launches with 358 successes. So there was one, and I had to really look this up a little bit more carefully. There's two missing here. One of them was a partial success. I would count it a success because we had we had Dragon, and we delivered Dragon to the station, and that is just, for me, that was 95%. Then we had one satellite, and because of a problem, we lost an engine on the ascent. We were not allowed to basically do a second burn, and then we deployed the satellite too low, and that's why this only counts as partial success. The other one that failed was flight number 20 or 19, depending on how you count, and that basically literally exploded in the air on the second stage. And there was also a interesting project. At the time, I think it was pretty miserable, actually. But I worked a lot on these things. That's why I remember them very well. So that's two then. There was another one that actually failed on the ground. However, that doesn't count because it happened on the ground. So I think I take two, but I count differently than Wikipedia. So the one thing, and I'll talk about that in a second, is Falcon 9 lands, or the first stage lands. And there's 325 landings so far, and the one last night was the 22nd landing for this booster. So by now, boosters have been used for 22 times, and that's pretty remarkable. Anyways, the rest of it, Cargo Dragon. Dragon delivers cargo to the space station. Started in 2012, in May, and the first successful landing refers not to Dragon, actually refers to Falcon 9. So we worked on the reusability and the landing of the rocket, but it took us 5 years to get it done at the end of the day. And you can see, in those 5 years, all that happened is 25 launches. That's amazing. I would have guessed it's much more. Because by now, basically, Falcon 9 launches every 3 days, I think, on average. So first landing was in December 2015, and then Falcon Heavy. You actually saw there was the video. There was the maiden launch in 2017. I thought it was February. Well, maybe that's wrong there. But anyways, Falcon Heavy launched by now 10 times. It's a really heavy launcher, as the name says. And then Dragon, being a cargo vehicle, always had a window, or at least the first Dragon had a window, right? And that was just a symbol for us. This is not a cargo vehicle, or not. This will not always be a cargo vehicle. This will fly astronauts at one point in time. And so, meanwhile, we worked on a second version of Dragon, or Dragon 2, or Crew Dragon, and that Crew Dragon finally launched in 2019. But the first astronauts, Bob, what's his last name, Benken, and Doug, I don't know, Doug Hurley, flew by the end of May in 2020. It's different. I mean, if you fly astronauts, if astronauts fly on your vehicle, it becomes a very different thing. Satellites are important, and they're billion-dollar satellites, and they're important, but they're not as important as humans. So flying astronauts was a new experience for me, and I must say it kind of grew on me, and I very much enjoyed. There were 2 missions after that I continued to do as launch chief engineer. One of them was the first commercial crew. When you do those missions, you basically, I at least had always a chance to meet the astronauts. I also met the German astronaut Maurer along the way, Matthias Maurer. So that was one of my highlights too. And then I flew. There was also a commercial crew called what was the name again? I should have paid more attention to that. Anyways, the first commercial crew with Jared Isaacman and Haley Arsenault, and 2 more. And it was amazing to work with private astronauts in this case, because the question then really boils down to, what do you teach astronauts? How do you make them a team? How do you select them? And all these things. It was basically what NASA usually does, was something that suddenly that we had to do. So very interesting, at least. Okay, the other development that happened was Starlink. By the time we launched Starlink, we kind of figured out we need to do something to move up in the business, basically. And because if you build a launcher and launch satellites, you basically depend on the launcher, on the satellite industry. And when the satellite industry is doing well, great. If the satellite industry is not doing well, not so great. And so by moving up into the satellites now, you kind of, you're now in control, basically, of your own business and have more business when there's more satellites. Starlink did really, really well. It has by now 6,000 satellites. That's a crazy number. They're all in a very thin shell around the Earth, and they all provide nothing but internet. So it's not like a broadband. It does not deliver TV. It just delivers plain internet. What you do with it is your problem, yeah? And that is something that does not exist in many places of the world. It's actually perfect for like non-urban or rural areas, desert, where few people live, basically, and there's no cable, no connection. I have it in Los Angeles. I still like it there, but it connects by now 3 million customers, and every customer pays $100 or 120, depending on where you live, a month. So you can imagine this actually is a real business in the space business, and that's also amazing. Quickly about reusability, the idea is similar to like an airplane. An airplane and a rocket are roughly the same cost, at least the smaller airplanes, 737 kind of size, is about the same cost as a rocket. You don't want to throw this away after each flight. It'll be a very expensive trip, obviously. So the idea is to recover the airplane or the rocket and do it again. And it was belittled. People made a lot of fun about SpaceX, and those videos have not lived the time very well. They're now fun to watch, actually. Anyways, I think the concept works. In particular, the thing that people said, oh, it's just too expensive to recover, you have to bring it back, you have to inspect it, you have to take it apart, and so on and so forth. There are ways to do this in an expensive way, but even if you're really expensive, it's hard to make it as expensive as a new booster. That's what we found. It's always better to recover it, it's always cheaper. And so it becomes a cheaper booster at the end of the day, and it actually lowers the launch cost. And the fundamental problem on space or space technology is actually not the physics. I mean, the physics are a fundamental problem, but the fundamental problem now that we have is cost. It is so expensive for a satellite that you build smaller satellites, and you can't really do what you want, and you have to wait for the rocket and everything. Yeah? If you solve this problem and make it cheap, then you can actually have access next month in a cheap way. That's the idea behind it. Yeah. The other side effect of that is, obviously, if you bring the vehicle back, you can look at the vehicle and you can try to figure out if it's about to break here or there, if things are not working, and you can look at more video cameras and so on and so forth. And so it actually helps your reliability, which I also worked a lot on. All right, that's actually how it looks. So the rocket launches on, is that a laser? I don't think so. So the bright line is the rocket launching, yeah? And then over there you see how it basically goes up. That is the booster, the lower part that separates from the second stage, turns around, and actually burns and tries to come back. And then the middle one on the right side, that is the so-called entry burn, where the booster comes back into the atmosphere. And to make this a little bit easier on the heat shield and on everything on the vehicle, it's basically like tapping the brakes. That's what that entry burn is. And then down there, that's the landing burn. And that's what you basically saw in the video too, only there for 2. If you paid attention in the video too, you saw the center booster missing the drone ship, the landing ship basically. Yeah? That happened really, and we were lucky that it missed it because it was way too fast. It's hard. The reason it is hard is actually the center booster burns longer on Falcon Heavy, and it just has a higher energy on the way up, and so it also has a higher energy on the way down. Yeah, switching a little bit on topic, the next big thing, and that happened largely after I left for SpaceX, was Starship and Super Heavy. That's basically the new rocket. And Starship is actually called, both things are Starship, but then if you talk about Starship, it could also be the upper stage, and the Super Heavy booster is the lower stage. 121 meter and 9 meters diameter. That is huge. It's amazing how large it is. It has 5,000 tons of LOX and methane. So now the propellant changed from kerosene to methane. It's a cleaner propellant for the engine. It's actually heavier than Saturn V. And the payload is about 150 tons. I've seen numbers, 100 tons, 150 tons. I'm pretty sure this is a number that will go up over time and start with 100 tons, something like that. And the trick, what is new on this one, well, okay, I'm gonna talk about that on the next page here. It's completely reusable. So it's not, when you look at Falcon 9, there's actually the booster comes back, but the upper stage actually disappears. It delivers the satellite to orbit, and then it deorbits itself. And deorbiting itself typically means it's in like remote place in the ocean where it gets dumped. And then for each launch, you have to build another second stage or another upper stage. The fairings that go around the satellite, by the way, those are also being reused. And that's because they deploy before the second stage finishes its work, so they're relatively slow. Starship, on the other side, is completely reusable. So in that case, you only have to pay for operations, the cost to build the vehicle divided by the number of flights, and propellant, which, by the way, is also a lot of money. But it is nowhere near what a rocket costs usually. It had a launch last year in April, and that ended pretty much after stage separation. I was actually there. It was pretty amazing. There was a second launch in November that also ended not great. It ended before reaching orbit. There was a third launch that reached orbit, but then both stages failed on re-entry. And then that actually got fixed in, I think it was on June 6th or 7th this year, just like a couple of weeks ago, and both stages landed. The first stage landed in the ocean, so it basically just softly in the water, and the second stage had a very traumatic re-entry, and it looked like it's not going to make it, but it actually did make it, and it performed the maneuver and landed also in the ocean. So the next time I would expect that they basically land on land so that the second stage can be recovered, and then the super heavy booster can also possibly be used again. The trick is to use Starship then in orbit and to refuel it. So in other words, now you have an upper stage that looks like a Starship in orbit, and you fly 10 other missions to refill it again. And then you can use that fully loaded Starship and fly to the moon or to Mars from there. And that basically is all you need to get to moon and to Mars. There's a reason why you should really make the launches cheap, because you do need now 11 launches to get to Mars. So they should be really cheap. There's other effects that Starship will have, and they are basically, it allows you to build heavier and I guess, cheaper satellites. Instead of having telescopes that are really, you can actually put a real telescope up there. 100 tons, I mean, that's what the mirror basically is, right? And then you build just a heavy mirror and just launch that. There's really interesting ideas on how to develop spacecraft or satellites in the future, and they all have to do with making those vehicles cheaper. All right, I'm going to go over this. I don't know, how much time do I have? Okay, I'm good. There's a couple of things that make SpaceX different. I mean, not just because Elon Musk is the boss, but Elon also introduced a couple features at SpaceX that resonated well with me, yeah? And that I basically think are features of SpaceX. Yeah? One of them is continuous innovation. When your rocket launches successfully, most companies don't touch it anymore, yeah? Because it worked once, don't change it. Yeah? There's almost like a myth of it's called also heritage on the on space flight. This is a heritage part, and heritage part means mostly people don't quite understand why it worked, but it works, and so it's going to be used again. Yeah? So continuous innovation means you continuously drive something down. You drive the cost down. You drive the reliability up. You reduce the weight. You do something. Yeah? And only when you really feel you can't squeeze it out anymore, then you stop working on it. Another trait of SpaceX was we actually did a lot of testing. We really did a lot of testing. I think the engines had like hours of runtime. And some of that is crazy when you look at other programs and they go, oh, I got 4 seconds here. But we always prefer testing over analysis. Yeah? Partly because even if you do analysis, you still have to test it, and then you find out what it really is. Yeah? And though you might just go start with the testing and then find out what it is and not spend too much time on the analysis there. I'm not necessarily against analysis at all, but there's analysis that distracts you a little bit from the testing. And then, of course, it comes with risk acceptance. Most people want to be successful, obviously, and SpaceX wants to be successful too, but SpaceX has no problem in risking a launch and saying, this launch might not work. Yeah? Expect this to fail. And then, of course, on Starship, the first 2, 3 basically had failures associated with it. The sad part for me is always, I look at the headlines and then they say SpaceX failed again. You go, well, they kind of knew that. They do this on purpose to figure out how far can they go with whatever, this part or that part. They could have actually analyzed the whole thing and they would still not have launched by now. Yeah? So risk acceptance is important. People are slowly talking about this and figuring out that this might actually be a good idea. Yeah? There is an element here when you make changes on something that does work, you got to be super careful. You got to really understand how things work and how things don't work. And that was something that I was really highly invested too. The last thing is actually something that is really trivial. When you have to make decisions, we basically made decisions almost as soon as we could, or actually not could. Even the hard part in business is to make decisions if you don't have complete information, right? And you have to make some guesses, and then you basically trying to make a decision on an estimate of what will happen. That is okay and better if you do it today than if you wait till tomorrow. If you have other information tomorrow, there might be cases where you change your decision, and that's okay too. Yeah? But I've learned always that making a decision early and getting an action, getting this whole thing going in the new decision is better, even if you change it later. Because in the majority of the cases, your decision was right. And so the majority of the cases, you actually gained, whatever, weeks of decision time. All right, this one goes one level down. Actually, it's more like almost like on an atomic level to some extent, yeah. And in particular, like on the first one, communication is key, brevity is a virtue. An email that goes for a page kills me, especially when you print it, by the way. You should never print an email. And then also, at the same time, the one thing that you can make longer is actually acronyms. Don't do acronyms. I mean, there are acronyms that are accepted. Like TU obviously is an accepted acronym. I think you probably all know that, right? I would hope. But there might be others that, where people go, I don't understand what this person is saying, and then looks it up, and it costs like 5 minutes, and that's just not right. On a company level, have a clear mission. And the mission of SpaceX is pretty easy. It is making humanity interplanetary. Actually, multiplanetary is the right term. Yeah, and that pretty much is in both, on one side, an incredible challenge, and on the other side, a very clear goal. I've learned that having people participate in the company growth through equity, in other words, stock or so, is a really good thing overall to motivate people. That is something that is very difficult in Germany, I know that, but I think it's still something that sooner or later would be beneficial. We had a culture of strong ownership. We owned things. So I knew that as VP for build and flight reliability, I owned the risk. It's not totally clear what that means, but it means if something is going wrong, it's my fault. And we had basically ownership distributed throughout the entire vehicle. It was always clear who owns something. Second to last, we had a meeting culture that allowed people to leave a meeting if they can't contribute. So in other words, if you go into a meeting and you can't contribute, or it's not something that you're interested in, you can just leave. And this is very subtle, but it actually makes the meetings better too. Because now people try to actually have a meeting that actually is relevant and interesting, so they don't have half the people leave in the meeting. And then last but not least, everything can be negotiated except mostly physics. We tried that a couple of times, it didn't work out. But everything else should be negotiated. All right, that's what I have. I have a couple references. One of them is, okay, Liftoff is a great book by Eric Berger, and Eric Berger is a great author. There's a new one coming out that's called Reentry. It's coming in September. It's the continuation of this story. This is Falcon 1, basically, continuation of that story into Falcon 9. I'm pretty sure it's going to be like a great New York Times bestseller. There's Return to Space was a Netflix documentary by Chai Vasahili and Jimmy Chin. Great people, actually. They've done way more important documentaries than that, but this one is a great one too. And they just tell the story. They tell the story and make you believe that you don't remember the end of it, right? Free Solo was from them too, actually. And then last but not least, there's the Walter Isaacson biography of Elon, mostly on Elon, focused on Elon and less on the team. Obviously, a very, very interesting book too, and I always say it's very accurate. It's accurate in the great picture. Yeah, that's pretty much what I have. Yeah, I did want to say one more thing. So it's really difficult to overstate the impact of a successful Starship on space exploration. And maybe I have been unclear on that in previous presentations or something like that, because there's still people that think Starship is not important or has no relevance for the European launcher. That is not the case. This will basically put everything upside down. And that's what I had. Thank you.
So Hans, thank you very much for this great presentation. I think even those that hadn't delved too much into your personal vita before now have a great first impression. It's still amazing to see that your career actually started here. Do you remember the smell of the room?
Yeah, there was, I think physics and math was in this room. I don't think I was at every weekly. It's hard to focus, especially when you sit up there, right? It's so far away.
Yeah, that's true. But as someone who devoted his life to space exploration, do you actually believe in extraterrestrial life?
So I think it's got to be there somehow. I mean, if I really think we are unique, then I feel like that's a little bit almost preposterous. So I think there has to be something else. It's just so hard to get to other places. The distances and and everything between them is just incredibly difficult to get there. So I might as well believe not in it, because it makes no difference.
If there was, how would you like to look? How would you like them to look like?
Oh, I don't think we have any idea. I mean, maybe like an octopus.
Now, you got a little tour in advance today where some of our fellow students showed you around the labs at TU Berlin. If someone of you doesn't know, actually the TU Berlin also has satellites in space. In another talk, you once said that SpaceX success also lies in the fact that you recruit directly from campus. So after the tour, will you give Elon a call?
Come again?
So will you give Elon a call after the tour now? Because you said that SpaceX prefers talent over expertise or experience.
Yeah.
And after the tour now, do you think?
Oh, well, so I mean, talent is also something you can develop, right? And so I think it does develop talent. I mean, you basically, I felt like when I started working on TubeSat, it felt to me like it's something that I don't know. It's like some talent on me was triggered by that, or some. I'm not sure. Haven't really thought about this, how to express this. Yeah, but it was something where I felt, oh, this is interesting, and I started working on things on my own, basically. Yeah, and Renna in particular had a couple of questions that would trigger that in me. So I feel like TubeSat has a tremendous impact on my career because of that, or rather the TU Berlin and the satellite lab, basically, and Renna as my professor in particular, because they triggered my curiosity in certain areas, basically. And okay, it's silly things like angular momentum. I thought was really interesting. And so I started programming and started building a program, and then I started to simulate it, and that became a simulator that basically for my PhD work, yeah, and that actually became the simulator for hardware in the loop for the rocket. So there's some stuff that started here with just a curiosity and then developed into actual tools and something really useful, both for you know, myself and for SpaceX too.
Did you have a favorite module at TU Berlin?
I have an echo in where I'm sitting here, and so I hear you.
Okay,
I hear you
sorry.
double.
Did you have a favorite module at TU Berlin?
Favorite? You mean like a class or something?
Yes. Yeah.
I had three basically. Yeah, I think obviously satellites was one of my favorite. Yeah, I had systems technology, which had not a lot to do with systems technology at the time, but it was actually non-technical, and I kind of enjoyed that part. Actually, that's two then. So those were my two favorite ones.
All right. Now, coming to your early days at SpaceX and looking at its history, you already said it, you guys were almost bankrupt in 2008 after 3 failed launch attempts, and as if this wasn't enough, you did them basically in the middle of nowhere. I think this requires quite a strong mental. So, yeah, how did you cope with these failures, and what is your strategy in general to overcome such situations?
So, yeah, there's an element to that that actually. So the problem was a little bit. BrainSat was successful, right? And so I was not used to failure. And so when the first Falcon 1 failed, I was a little bit like, shocked maybe, or I didn't know how to deal with that really. So I needed some time to recover after that. When the second failed, well, by that time, I think we felt a little bit better because the second one flew actually way further. It flew basically, it went out of sight. And if you compare the two failures, one of them you're picking up the pieces, right, for like a day. And then the second one, it's out of sight. That feels way better. But then on the third one actually was going back to that like midway, where you see the two explode in midair. And that wasn't great either. So by that time, you may question yourself a little bit and say, is that really the right thing I want to do, or should I do something that's a little bit easier for me? The good part was really, we did the fourth one so quickly after the third one that you didn't have a lot of time to dwell on that. And Elon was also, Elon basically, when we came back from the island after the third attempt that failed, he put everything everyone in the meeting room, and then he said, all right, you got, I think he said 4 weeks, or maybe it was 6 weeks. You got 6 weeks, we got another rocket, you go back and fly it right away. And there was so much work with that to get this done that you had no time to really dwell on any doubts about yourself at that time. And so you get over it. And then fourth one obviously was working, and that was amazing too. I mean, we didn't consider that really. We had a ground station scheduled, but then the rocket came over the same ground station again, and so we just called them up and said, stay on the ground station for another hour. It will come over us again, yeah. And then it happened, and the rocket didn't have any solar cells, so it just runs on the battery, yeah. And so we saw the rocket, basically the battery going out over during the contact with the launch site, basically. And so, I mean, A, we proved that you can actually get to orbit, and B, it's apparently round, right? So that was a good day.
That's all that counts.
Yeah.
Yeah, I think failure and testing is a good keyword. You said that at SpaceX you work with a culture of like fail fast, fail often in order to test. Do you think that in Germany people tend sometimes maybe to be too perfectionistic?
I've seen this in some of the aerospace attempts that they take low risk, yes. Yes, otherwise, I mean, in terms of failure, I try to take the Deutsche Bahn a lot, so. So I would agree that usually we take not enough risk in this country here. But failure we have enough too on the other side when it comes to that. Yeah, I don't know. It's a subtle thing to accept that and say, okay, this can actually go wrong. On university level, you can do this, and I'm pretty sure that hasn't changed much. The way Renner basically did accept it when his students would fail on certain tests. Yeah? That's important, actually. That's really important. Yeah? On the national level, to build a satellite that's $500 million, well, that should probably be, very carefully evaluated. There's a middle class in between where you can still take risk. Like smaller satellites, not that much money, you have maybe more than one satellite. And that's where you should actually test things and push things. If you don't take the risk, things will just not move. Yeah.
I think risk is another great keyword. During your time at SpaceX, the company had also engaged in some controversial decisions. I think there were several incidences where you guys decided actually to launch a rocket, although you could not rule out some risks or hadn't had the clearance of national agencies. So what is your personal attitude to risk-taking, maybe also in your private life? I saw that you're a pilot, actually. And what would you recommend to our students? And did these decisions also make you sometimes feel uncomfortable?
So I own the risk. So to some extent, I mean, at the end of the day, if we identified a risk, we would bring it up and then basically bring it up to Elon at one point and provide a recommendation. Yeah, and in many cases, actually, we had like certain criteria. We do Monte Carlos and we evaluate basically what we do some analysis after all. The landing is whatever, it's going to happen with 95%. However, this one in particular is 90 because of wind, and then we would say, okay, I think that's still enough. Yeah, so we'd take an active risk basically. Yeah, it's for me, I always felt that it's important. I do take some risk on the personal level too. I'm a pilot. I fly. I dive, or I don't dive anymore, but every time before I do that, I'm aware that this is risk, yeah, and I do work on what can I do to mitigate it, what can I do, I mean, other than not fly or not dive, right, or not ski, that's an easy answer, but I feel like still you have to take some risk and evaluate. There's also sometimes you have to stay home when the weather's bad or something like that, obviously, yeah, but you have to basically go through the process. And honestly, every time, especially diving, I was always a little bit worried about diving and before I do that, and make sure that I'm well trained, or know my stuff, everything's working, equipment is working. So yeah, it's important.
Did your job also maybe set you up to use a checklist every time before, or?
I'm really bad at checklists. That's really amazing. I try very hard to actually stick to the checklist, but every time I have to remind myself, just stick to the checklist.
That's great. Now, with this, I would actually like to open the room to questions from the audience. So if you have any questions, raise your arm. There's just one disclaimer, so please do not refrain from any political statements or comments today.
I wouldn't give them anyways.
Yeah, such questions we have to skip, unfortunately. Today is under the hood of science. So, Patrick and where's Jonathan? Ah, he's over there. Do you have a question already?
I do, yeah. So it was very fun and intuitive speech. Thank you for that. One question is that, I had two questions, by the way. The first question is, today is Elon Musk's birthday. Did you already get a chance to wish him today?
I can't hear that.
I couldn't understand.
Okay, it's not just me. Yeah. How do we do this?
Yeah, can you repeat the question maybe again?
Yeah, I can. So I was saying that today is Elon Musk's birthday. So did you get a chance to wish him yet?
I think it's Elon Musk's birthday? It's Elon's birthday.
Yeah, it's his birthday. Happy birthday.
Yeah. Okay. All right. Yeah.
No, I'm aware of that. That was the day we actually blew up one of the rockets, flight 19 or 20, that happened on his birthday. Ever since then, we don't launch on his birthday. I'm not sure if he launched today.
All right. So next question. Patrick is coming around.
Hi. I'm Mara, and I'm also studying at TU Berlin here. I'm studying CS, Computational Engineering Science. And my question would be, what is your worst mistake that you've ever made? And it's just like very, very, very bad, but you're also glad that you actually did that mistake. Number two is...
by the way, only one question.
Oh, only one question. Yeah. Well, all right, then...
There are so many people today, I'm sorry.
Yeah, all right, then
okay.
That would be my question. Thank you.
I don't mind hearing the other one, because that's really difficult for me.
Okay, so maybe then go on with...
I mean, it's not that I don't have like a huge arsenal of mistakes available. What's my biggest mistake?
Maybe you collect the next question and you...
If you give me the next question, I can think about this during that.
Yeah. All right, next one.
Hi. First of all, thank you so much for that presentation. It was very inspiring. I was wondering, why do you think it is so important that humanity becomes a multiplanetary species?
All right. Okay, good. Going back to the other question. And I do appreciate that you didn't ask me for my second worst mistake. All right, I mean, obviously there's personal mistakes too, probably. Let's see. So the second launch on Falcon 1, I always considered to be my failure. And that's because it was a guidance and control problem, and that was my background, guidance and control. So I could not, it took me a long time to get over that on the second launch, and not that I should have spoken up. And that actually is the type of failures, basically, that I have a lot on my side, that I say, I should have spoken up earlier, or I should have probably said something like that. And I'm still working on, is this really right? Is this really by the time? And so I'm just thinking too slow in that case, or maybe I'm not speaking up quickly enough. But that changed over time too. So I do think that I do speak up earlier now when I see something that is not right. So I hope that answers that question. Back to the why do we need to go to Mars? Okay, there have been 5 mass extinctions on this planet, and they have been pretty far apart and like millions of years and so on and so forth, but we are kind of dependent on this planet to survive, basically. And I mean, we're not really taking great care. That's one element. We obviously need to take greater care of the planet on its own. That's one thing. And none of this actually should say we should not take care of this planet. The fact that we want another planet is a pure backup plan in case of meteorite or volcanic eruption on a really high level. It basically just is a backup to preserve humanity in case something happens to this planet. And it's also the next step to become a completely multiplanetary species. The best example for me why to do this is actually the Natural History Museum. Yeah? If those dinosaurs had rockets and would be able to go to Mars, you will still see them today.
All right, next question, Patrick.
Thank you for your nice speech. You said that costs are the limiting resource for space exploration. So I wanted to ask, so how expensive was it? How much did you get it down now with SpaceX? And what are you aiming for? So how cheap should it be?
Yeah, it's a good question. And part of that is, I don't think I can answer the last part, how much should it be. So the development of Falcon 9 was roughly $300 million, which is surprisingly low. I wouldn't be surprised if there's some additional millions here and there, somewhere. But Dragon development was about 400 million. And this was done under a contract that's called the COTS contract from NASA. It was a new way of developing a spacecraft. It was basically asking the company to invest into the same project. And so the investment of SpaceX was Falcon 9. The investment of NASA was Dragon at the time. 400 and 300 million, maybe probably half and half, something like that. But anyways, a relatively low number compared to, I just read today, Ariane's 5 billion, and that's probably also a low ball. A launch itself right now is I think it's 69 million, right? That is by far the lowest cost launch you can get at these days. The next launches are higher. And I believe actually what drives the cost down is the second reusable rocket, because then you actually have a competitor that actually gets the prices down. In the meantime, you actually recover the cost of the development of the reusability, which in itself is also a fairly expensive piece. I've been trying to piece together the financing of SpaceX over a long run. It's very difficult to do this over 20 years. And a lot of private investment has gone into the company to the amount of basically billions. And now the company has Starlink and is able to basically get billions as an income and can finance it itself. So that's the benefit. I hope I answered your financial.
Thank you very much. A quick remark at this point. We're unfortunately a bit behind schedule today, and the schedule is actually quite tight, so we will have time for 2 more questions. Jonathan, do you have already someone?
Hi. Does it work? Yeah.
Yep.
I want to ask, how many people did you work with that you consider smarter than you?
A lot, actually. There's remarkable smart people at SpaceX. It's really amazing. With people that could remember like Game of Cards, all 32 in its order, and had really good, also good education in physics and everything. I don't know. I would say I would rank myself probably in the 75th percentile at SpaceX. So SpaceX at 15,000 now. So take the 75th percentile, and then that's the other ones are smarter than me.
I think there's actually a quote from your competitor, Richard Branson, who said, if you're the smartest in a room, you're probably in the wrong room. So yeah. It's always good to work with very smart people, yeah. So last question for today.
Hello, Dr. Hans. It was an honor to be here and to listen to you. So I wanted to know that SpaceX has thrived on the methodology of vertical integration, and but today we hear that the private investors today who are trying to invest in small space companies, they don't prefer companies to build everything on their build maximum of what they can on their own, as SpaceX has done. So what do you think, that companies today, should they focus on vertical integration more for their companies when they're trying to come up?
So basically you're asking me about what I think of vertical integration after all those years? Or vertical integration, with building everything in the house?
Yeah.
Okay.
Yes.
So, okay, I can tell you that I think it always resonated with me. Yeah, it made sense. There's two things that made sense. One of them was we did the most difficult thing first. We developed an engine first, and we basically did this with the argument, this is the most difficult thing, we got to start today. Because sometimes companies pick the easy part first, and then they show progress, and then at one point it hits you, you're just very late on your engine. So we always, I think, or mostly, not always, but mostly did the right choice, and this is the hard part, let's work on that right away. The second problem on buy versus build, to me it made sense to build a lot of stuff. The aerospace marketplace is really not great. It's mostly expensive, it's mostly stuff that's old, and it's mostly stuff that also doesn't really have really high quality. There's a number of reasons for that, probably too long to really go through this today. But we also made a decision towards, let's just build as much as we can, because then we control the quality, we control the cost in particular, and most importantly, we control the schedule. People love signing you up for some product, and then they deliver the first one maybe on time, and the second one a little bit later, and then they also raise the price. It's difficult. I've only met very few vendors where I would say, these are great people, I would always work with them, they deliver on time, and they don't raise the cost, they're reasonable people. But the majority of them was always difficult to work with.
All right, so thank you very much for all your questions. Before we come to the final, Aurel and Ben, the chairs of the initiatives that are hosting us today, have prepared something for us.
Okay, so hello everyone from our side as well. I'm Aurel Gröbel, I'm the representative of the Bears Club at TU Berlin. This is Ben from REV Inc. Together we organized this event with Vincenz. Thank you, Hans, for coming. Thank you, Vincenz, for doing this amazing talk. So we wanted to quickly introduce what our initiatives actually do at the university. And we are always searching for students who are motivated, who like to work on things, especially in our case, engineering stuff. Of course, also so for senior supervisors who would like to have a look at what we're doing and tell us, no, that's wrong, do it different. But yeah, we prepared a little video on bears, and we would like to show it now. And then afterwards, Ben is also giving a short introduction to what REV Inc. is doing. Thank you very much. There's a student initiative at the Technical University of Berlin, which works on different space projects for students. We were founded in May 2022, 2 years ago, by students and research assistants at the Chair of Space Technologies.
Hi, I'm Eric. I'm the leader of the experimental rocketry group. We are divided into two subgroups. We have first the propulsion subgroup, which is developing a bi-liquid engine, which is working with LOX and ethanol. And the goal is to develop a 3 kilonewton engine, and we have our second subgroup, which is the rocket systems, which is developing all systems we need. And right now we are preparing for our second launch and having the CDR coming up for our third rocket, which already shall fly above 3 kilometers in apogee.
Hi, I'm the leader of the robotics group. We are mainly dealing with robotic exploration as well as ISIU technology, and we have 4 different projects that are currently going on. One of the projects is the development of a Mars rover that is competing with other student teams at the European Rover Challenge. And then there's another project that we're doing in cooperation with other students club from all around Germany, which is also developing a rover as well as EVA tools that will be tested in the Lunar Hall in Cologne.
Hi, I'm Matteo Grube, and I'm the head of the Science and Experiment Working Group. We currently have two major projects underway. The first project is Career. This is about researching and testing the docking of satellites. Docking satellites is important to be able to interact with other satellites in the future. We have two UR robot arms for our laboratory. In our second major project, 14 students are taking part in the Rexus-Bexus program run by DLR and the Swedish Space Agency. In our experiment, we want to analyze the behavior of liquids in the metallically printed tanks. To do this, we have 6 different tanks on board and record the fluid behavior with cameras.
So, hey, I'm Ben. I'm the chairman of the student initiative AG Wien. AG Wien stands for Arbeitsgruppe Wirtschaftsingenieurwesen, and we have almost 200 active members. Even though our name says Industrial Engineering and Management students, we welcome students from all different kinds of degrees. We help our members to develop and network both professionally and personally. We achieve this through projects, events, and cooperations with companies. We also are part of a German and European network of students. And of course, with the students, we also have a lot of fun activities weekly planned. On the professional level, we have cooperations with companies like with technical companies like Bosch, Tesla, and Stadler, but also with companies such as KPMG, DTCon Consulting, and McKinsey. If I was able to spark your interest in those very few short seconds of presentation, you're welcome to scan the QR code. It will direct you to our Instagram page. We meet once every week on Monday at 6:30 in the Vivi Café of the EB building. If you have any further questions, you can add us on Instagram, message us, or in the exit there are going to be a few of our members. You can speak to them directly. Thank you so much for your attention, and Vincent, the stage is yours.
So now it's time for some acknowledgements. So first of all, huge thanks to Dr. Königsmann, without whom the event would not have existed. So again, thanks for being so kind and open right from the beginning. And as I already mentioned, it started via a simple LinkedIn message. Then, such an event is not possible without an extraordinary team. And the team includes, so Ben and Aurel, you just saw, Jonathan Thelen and Johanna Müller, also Patrick Merino-Wischniewski, and also special thanks to Juliane Wistuber, Imke Schramm, Anna Groh, Dominika Gericke, and Bettina Sartori, who supported us from the TU Berlin side. So thanks a lot. All right, so that's it. So thank you all for being here today. It was an amazing experience. Come back home safely, and then see you on campus.